Okay, so last question from the non-calculator in 2016. Again, I can't stress enough how interesting it was to see that 3, 4, and 6 are looking very similar to things we've seen in our past, which is good. This is the first time all our review is really starting to pay off and hopefully make these questions a little more approachable. Number 5 was the curveball, and again, the majority of 5 isn't assessed. The only part that's assessed this year is going to be question C, which is that related rates type question. Again, that's if they decide to include that. Who knows? Know everything, but be prepared to not see everything. I mean, in a way that kind of makes it equitable to everyone, but that means you really need to know all of calculus and be comfortable with it so that when you see any part of it, you know what to do. Okay, anyways, let's dive into question 6. Last time I felt like I was talking too much and I was getting scared. Okay, so I need to write the equation of the line tangent to the graph k at x equals 3. First, let's evaluate what k of 3 is. K of 3 is f of g of 3. So we're just replacing x so far. Now that's f of, well, what is g of 3? So we look at our chart. G at the x value 3 is 6. But what is f of 6? Okay, f of 6 is 4. Okay, so now we know that k of 3 is 4. That's nice. Now we need to know what k prime of x is so that we can know the derivative, because if we need the equation of a line tangent, we need an x value, we need a y value, just found it, and we need the slope at that x value. So let's find k prime of x, and then we'll plug in 3. This is essentially the calculus version of the chain rule. Like the formal definition of the chain rule is what's really going on in this problem. So there we go. That's the chain rule. Derive the inside times the outside derived with the inside plugged in, the original inside. And now let's find k prime of 3. That's g prime of 3 times f prime of g of 3. One thing I'm emphasizing here is notice that I went really step by step. You want to do the same thing here. Don't just cut to multiplying everything together and get your final answer. At least make it clear in order that you just found g prime of 3, which is 2, and that's being multiplied by f prime of, let's just do g of 3 next. We'll go one step at a time, which is 6 again. So now it's 2 times f prime of 6, but f prime of 6 is 5, so we get 10. All right, so the line tangent to k of x, say at x equals 3, is y minus y1 equals the slope and x minus x1. You don't have to solve it for y. Maybe you do because you want to. It doesn't take too long to move that one variable over, or maybe you just do that at the beginning. Okay, that's part A. Let's move on to part B. So now it's time to do the quotient rule. Again, this happened in 2017. I really said I could definitely see them doing this because this really gets at the fundamental idea of all your big derivative rules without getting too messy with the algebra. Okay, so we have f of x times g prime of x. So bottom times the derivative at the top minus, so the order matters here, the bottom derived times the original top, all over the, I'm going to write it like this, the bottom squared. All right, so again, when you fill this out, well, technically that's done there. When I go to find h prime of 1, I'm going to just fill things out in place where they used to be and not simplify anything yet to show that I was clearly getting particular values. If you make maybe one mistake here, they can see your mistake and maybe be more lenient for you. So anyways, we have f of 1, which is negative 6, times g prime of 1, which is 8. Keep the minus in between. Now f prime of 1 is 3, g of 1 is 2. Get to use every number. And then we have parentheses, I guess I'll use now, or maybe I'll still keep the brackets. Brackets are fun. F of 1, which is negative 6, squared. Okay, now I'm going to simplify. So that's negative 48 minus 6 over positive 36, which is negative 52. I guess I'm going to write it like this. All these have a 6 involved in it. Negative 52, or sorry, 54 has 9, and then says, so it's negative 3 over 2. That makes sense. Yeah, I guess you should have taken the 9 out instead of a 6. If you take a 9 out, no, there's more you can take out. Anyways, I feel pretty confident about that. I'm not going to check my work now. I'm just going to keep on moving along and check it at the end. Okay. Gosh, no, I'm not. I'm going to figure it out. 54 over 36. If you take out, yeah, you'd have 9, you'd have 6. Okay, whatever. Up next, evaluate this crazy thing. So again, this is kind of a fundamental theorem of calculus question. Really big idea going on here. First, just rewrite what's going on here. F double prime of 2x dx. Now this is technically like a u substitution question if you want it to be. You know what, I will do that since we haven't seen this in a while. So I'm going to say let u equal to x. That means du is equal to 2 dx. And that means du over 2 is equal to dx. Okay, so now what I'm going to do is I'm going to rewrite this in terms of u. So let's see here. First thing is let's change our bounds of integration. If it's 1 in x, then it is 2 in u. Because again, if you substitute 1, u equals 2. So now the bottom bound is 2. And the upper bound, if you plug in 3, is now 6. And this is really f double prime of u du with a 1/2 popped out from this term over here, or it's f double prime of u du over 2, but you can kick the over 2 out. Now why am I doing this? Just so I don't have to worry about the chain rule really when I do this. So now what I end up getting is I end up getting 1 over 2 integral, actually I'm going to integrate now. If I integrate the double derivative, the fundamental theorem of calculus says I will go back to the single derivative. And we'll evaluate the single derivative from 2 to 6. Right, so again, because I've done the chain rule here, I'm really just having f prime of 6 minus f prime of 2, and all that's going to get multiplied by that kind of constant 1/2 multiplying out front. Okay, so now it's time to look at our sheet, or that table. So that's 1/2 times f prime at 6 is 5, and f prime at 2 is negative 2. So this is 7 over 2. And done. Fundamental theorem of calculus. Don't forget about it. All right, let's see how we did. So 2 points for getting the correct slope of 10. Yay. And then 1 point for the line tangent. So yeah, they did solve it for y. But technically point slope form is still the equation of a line. I do think you could stop here, but how much harder is it to move that 4 over? Okay, up next, again, you can see that they did the exact same thing I recommended doing. Now this is more so not that they need you to do that, but this clearly shows what you were using for each value rather than jumping straight to this. I know it's tempting because you think you need all that time. But again, as you practice more and more and more, I mean, I'm not going through these questions faster intentionally. I'm going through them faster because they seem so familiar to me that I didn't have to spend as much time going over them. And I'm also not explaining as much because we've seen similar questions in the past before. So again, hopefully you're getting these down faster as well. So again, I say that to say, because you're going to be moving faster, don't skip steps like this. Whenever you substitute something from a table, make it clear. Don't simplify. You can simplify after, but at least have it written down where you clearly changed. Okay, and then last but not least, they pretty much did it the exact same way. only they didn't explicitly use U substitution. Now again, I'll be honest, I wouldn't have used U substitution either. I would have just, known that the chain rule is going to have that 1/2 that has to pop out to balance out the 2x that's going to get derived when you go back to f double prime. But you can use U sub, and I just thought I would throw it in there just to review it one more time. So hopefully it didn't throw you off. Hopefully either way you still got this answer, and hopefully you really grasped the fundamental theorem of calculus concept that integrating a derivative will take you one derivative back from where it began. So again, since this was the double derivative, we went back to the single. If we integrate the single, we go back to the original, so on and so forth. Yeah, so that's about it.